The gypsum relief, with the Aletsch Glacier in the centre, is the work of the Swiss topographer and relief builder Joachim Eugen Müller, who lived from 1752 to 1833. Müller was a trained carpenter. He also worked as a mountain guide, mountain topographer, and relief artist. The relief marks a groundbreaking work of precise topography of the Swiss Alps. Müller must have spent a lot of time in the mountains and probably climbed many of the summits himself. Joachim Müller took measurements and made sketches before he modelled his Alpine landscape. His model is remarkably accurate, even by today's standards. The relief landscape of the Swiss Alps, as acquired for the Berlin Kunstkammer at the beginning of the 19th century, originally consisted of 10 parts. However, according to current knowledge, only part 6 with the Aletsch Glacier has been preserved. In her doctoral thesis, art historian Eva de Letschel traced the background and history of the relief. Topographical reliefs were booming in the 18th and 19th centuries due to advances in land surveying and also impressive craftsmanship. Therefore, they were popular collectibles. On Müller's behalf, the Reverend Joseph Maria Businger, who lived from 1764 to 1836 in Lucerne in Switzerland, sold the relief in 1805 to the King of Prussia, Frederick William III. Businger even had a specific description printed for this purpose: depiction of the most peculiar part of Switzerland in sublime work. The models received a lot of interest from scholars and the public in Berlin. A letter from the German writer and pedagogue Heinrich Zschokke to Businger, dated March 23, 1806, states, "First, Alexander von Humboldt, based on his expert knowledge, recognized the full value and even expressed the desire of continuation. Finally, in 1821, the last 2 parts reached Berlin." The room-filling relief of the Swiss Alps, consisting of 10 individual blocks, was one of the main attractions of the Kunstkammer collection. Topographical reliefs enabled the viewer to control or conquer a vast and intangible nature. Thus, they were a political symbol of power and a symbol of the control of nature. The omnipresent seeing from a bird's-eye view on the relief complemented the balloon flights that were emerging at the time. To carry the Alps in miniature to Berlin not only represented the potency of the Prussian king, but also showed the viewers in Berlin a region they hardly knew. The object refers to the emergence of modern alpinism and the topographical exploration of landscapes at the end of the 18th century. After the Kunstkammer was closed, the architectural and landscape models moved to the Academy of Architecture on Schlossplatz. The Geographical Institute of the then Berlin University, today Humboldt-Universität zu Berlin, had its first site there from 1887 to 1902. In 2010, the surviving relief was rediscovered in the attic of the Geographical Institute in Berlin-Adlershof. The relief was identified as subsegment number 6 of the extension acquired in 1820. It includes the representation of the Upper Rhone Valley with the Aletsch Glacier at its centre, the Lötschen Valley, the city of Brick, and the Simplon Pass over 200 years ago. The model shows the landscape before any industrial developments in the mountains, for example the construction of reservoirs and facilities for tourism, and finally also before the beginning of man-made climate change. The many landforms of a glaciated high mountain range are vividly shown in this model. The massive glaciation of the last ice age covered the mountain and carved through valleys into the landscape. These valleys, with flat valley floors and post-glacial fillings, are exemplary in the Rhone and Lötschen valleys. Closely linked are the occurrence of glacially formed trough shoulders and so-called hanging valleys as major landforms. Müller even modelled in detail the narrow gorges of the mountain streams from these side valleys, which were carved into the trough flanks after deglaciation. Formerly glaciated landscapes show passes planed flat by glacial erosion. such as the Simplon Pass, whose road course, which already existed at the time, Müller has notched into the model. The many glacial overdeepenings filled with water after the ice had melted led to the many mountain lakes. Müller used small mirrors to recreate these mountain lakes. For example, the lakes in the moraine landscape of Bettmer Alp, Lake Schönboden and Lake Bettmer, now enlarged by a dam. He depicted cirque lakes in the outskirts of the Simplon Pass and the vicinity of Großes Schienenhorn and Blinnenhorn south of the Rhone Valley in great detail. Other lakes of the 19th century, such as the famous Merjelensee, an ice-dammed lake formed in the southeastern bend of the Aletsch Glacier below Eggihorn, no longer exist today. Lake outburst floods of the Merjelensee led to devastations down the valley several times. Given that the Aletsch Glacier became smaller since the beginning of the 20th century due to climate change, this lake exists only as a small remnant because the ice barrier of the Aletsch Glacier no longer dams it up. A central part of the relief is the longest valley glacier in the Alps, the Great Aletsch Glacier. If Müller had worked on his model at the end of the 19th century, the Aletsch Glacier would have been even larger. In the course of the so-called Little Ice Age, a series of episodes with very snowy winters and cool summers since the 13th century, glaciers advanced everywhere in the Alps. The furthest advance did not occur until 70 years after Müller created his glacier model. Since then, it has become warmer and warmer, firstly due to natural climate variability, and then, from the second half of the 20th century, due to man-made climate change. Consequently, glaciers melt and gradually become thinner and smaller all over the Alpine region. Many smaller glaciers will soon have vanished. At the overdeepenings of the former glacier-covered bedrock, many new lakes will form by the end of the 21st century. For example, at the Concordia Platz, where nowadays the large branches of the Aletsch Glacier meet. In the past, landscapes gradually evolved over millennia to their present shape, alternating between cold periods with complete glaciation and warm periods with few or no glaciers. Due to industrialization and mass tourism in the mountains, human impacts in the age of our so-called Anthropocene are now happening at incredible speed. By burning natural gas, coal, or petroleum, humans are changing the Earth's climate at an unprecedented rate. How drastically humanity changes the climate also depends on whether and how quickly we succeed in transforming our society and economy into climate neutrality without any further emissions of greenhouse gases. The preservation of natural forests with sufficient biodiversity and climate-friendly agriculture also plays a significant role. In the best case, with a warming in the Alpine region of no more than 2 degrees, the Aletsch Glacier will remain a large valley glacier. Unfortunately, the warming in the mountains is stronger than in the lowlands, and thus, for the Swiss Alps, it will be at least twice as strong as the global average. In a medium warming scenario, only small valley glaciers at high altitudes of the Bernese Alps will persist at the end of the century. In the worst case, with a warming of 4 to 8 degrees in the Alps, that is, with up to 4 degrees of warming worldwide, only a few isolated small cirque glaciers remain just below the highest peaks at elevations between 3,500 and 4,000 meters above sea level. The fate of the Alpine glaciers, as well as the future of our planet, is in our hands. It is up to us to stop further global warming. It should be our common goal that in 200 years, people will still be able to marvel the Aletsch Glacier in real life, just as people did when the gypsum relief was created by Joachim Müller 200 years ago.